Hi there, I'm going to talk about the periodic table today. So we organize the elements in this amazing table, and we're going to talk about that today. So when you go to the store, you see everything's all arranged by categories. We classify things that way so we can find things pretty easily. So the periodic table is arranged really nicely. You're going to like it. So how do we decide to organize them? So let's see. We decided to use properties. So chemists decided that all the things that react the same way or similarly, we're going to put them in a group. So we're going to call that a family. So these elements, chlorine, there's chlorine gas, bromine is the liquid, and iodine is the solid there. They all have similar properties. They like to react the same way, in the same fashion. So all of these are called halogens, and they like to react the same way. Even though they have different masses, they like to react with other elements in the same fashion. So they're called halogens. So Mendeleev was the professor who, the chemist who set this up. He was trying to explain elements to his students, and he was just trying to find a way that would make sense to his students so they would understand. They knew quite a few elements by the time he decided to make a periodic table. And he thought if he put each element on its own note card and then try to figure out a way to organize them, his students would understand better. And so this is why he did it. And there was other people who were working on it at the same time, but I think Mendeleev came up with it first. So he decided to arrange them in order of increasing mass. And because we can organize them that way, we can figure out and predict properties of elements that had not been discovered at that time. So that's why he got the Nobel Prize, because he could use this table to understand and then predict elements that they had not discovered at that time. So that's why it was a breakthrough. So here was his early edition of the periodic table. He's from Russia, so this is in Russian. And he set his up in a slightly different way than we have now, but this was the very beginning. This is the rudiments, the start, and he was putting down what they knew at that time. And then there were places where he had question marks because they had not discovered those elements yet. So he was able to predict ahead of time that these elements should be in this group and they're going to react a certain way. So that was the breakthrough that Mendeleev did. So how do we have it organized today? So now we organize everything by increasing atomic number. You remember that's the little number up top here? And each one is the number of protons. So we organize by the number of protons, and it goes from low numbers to high numbers. Remember, this is a group or family. These guys act the same way. These are the ones that we're just showing you, the halogens. They react a certain way. These guys are really the bad boys on the periodic table. They're going to really want to grab an electron from somebody else. So these guys act the same way. So the periodic law says when elements are arranged in an order of increasing atomic number, there's a periodic repetition of their physical and chemical properties. So it's really powerful the way the periodic table is set up. So the properties of the elements within a period change as you move from left to right. So that's across the periodic table this way. And the pattern of properties repeats as you go through each period. Period 1 acts the same, 2, 3, like that. So there's a pattern. So that's why it's called a period. It's periodic. Every period has that pattern. So there's three broad classes of elements that we need to know. They're metals, nonmetals, and metalloids, and we need to know where they are on the table. So across the period, the properties of elements become less metallic and more non-metallic, and I'll show you that in a sec. So all these ones in yellow, most of the elements on the periodic table are metals, so yellow is metals. Hydrogen is kind of an oddball. He's listed over here because of his structure, but he really acts more like the nonmetals. And the metalloids are right here in the center, the green ones, and they act halfway between metals characteristics and nonmetals characteristics, and these are the elements that we have in all of our electronics, the semiconductors that you hear about. So metals are here, nonmetals are there, and metalloids are the green ones. Metals are good conductors of heat and electricity, so copper, we use that in electrical cords because it lets electricity run through it. And we use metal for pots and pans. 80% of elements are metals, and they have these characteristics. They are shiny, they can be pulled into a wire shape, and they can be hammered or moved around and change their shape. That's malleable. So here's some uses of different things. This, the Gateway Arch in St. Louis is iron. Got some copper, aluminum. You know what metals look like. So we use this for all of our electrical copper. Nonmetals are the opposite. They don't let heat and electric current go through them. And they're usually gases at room temperature. Metals are going to be solids. And some nonmetals are solids, such as sulfur and phosphorus. They're solids at room temperature. But most of them are gases. And a bromine is that dark red liquid I showed you. Metalloids are halfway between metals and nonmetals. Behavior can be controlled by changing the conditions, so that's why we use them in electronics. And if we put a little tiny bit of boron mixed with silicon, we can make these wafers, and then these are going to be used for silicon. The silicon is going to be cut into little pieces with circuits shapes run through them, and then we use those in all of our electronics. So let's see how much you remember from this section. The table is arranged in what order? So what do you think? So remember, atomic number is how we go bigger and bigger and bigger on the atomic number, which is the protons. So how did Mendeleev set his up? So here's that Russian professor. So he did it by mass. So his was the beginning. He did by mass, and then now we're changing it to protons. And what's not true about metals? So they are actually, that's the opposite. They allow heat and electricity to run through them. So I hope you learned a little bit about periodic table. It's super fascinating. I love the periodic table. So we'll learn more about it as we go. Thanks a bunch. See you soon.